Hello, dear students. This is Dr. Sourav Sir's class. We are doing some questions or solving some questions about statistics. So, hope you are doing well and studying hard for your examinations. So, this question is telling us that let x1, x2 xn be a random sample from n mu1, the normal distribution of mu1 distribution, where our mu is unknown and mu is a real number. Okay, in order to test h naught when our mu equals to mu naught against h1 mu greater than mu naught, where our mu naught is belonging to r, so our mu naught is a real number, is some specified content constant. Consider the following two tests. So option A is telling us that reject the hypothesis h naught if and only if our x n bar is greater than c1, where our c1 is such that p mu naught when our xn bar is greater than c1 equals to alpha belonging to 0 1, and our xn bar is what? That is the normal mean, that is equals to 1 by n, and 1 by n into summation of I is running from 1 to n xi. And option B is telling us that reject h naught if and only if the median of x1 x2 xn greater than c2, where c2 is such that probability mu naught p mu naught of the median is greater than c2 equals to alpha belonging to 0 1, open 0 1. So then which of the following statements are true? So our option A is telling us that the test described in A is the uniformly most powerful test of size alpha. Option 2 is saying the same thing for B, and option 3 is telling us that P mu when our xn bar is greater than C1 is going to 1 as n is tending to infinity for all mu greater than mu naught. And option 4 is telling us that p mu naught when our median is greater than mu naught is equals to a half. So what will happen? So to analyze the given problem, we evaluate each statement using the properties of hypothesis testing, the normal distribution, and the uniformly most powerful tests. Okay. So now we are going to evaluate test A. So the sample mean, that means my xn bar, is a sufficient statistic for mu under the normal distribution due to Neyman-Fisher factorization theorem. Moreover, under h naught, this thing, our xn bar can be approximated by normal distribution of my mu naught and 1 by n. Now, for the one-sided test, our h1 when our mu is greater than mu naught, the likelihood ratio test LRT based on xn bar is uniformly most powerful at level alpha. Thus, our test A is the UMP test. So, our statement 1 is true. Yeah. So, now we have to think about our option 2. So 2 is telling us that the test based on the sample median is not sufficient for mu under the normal distribution. While the median is a robust statistic, it does not provide the most efficient test for the normal distribution compared to the sample mean. Therefore, our test B is not the uniformly most powerful test. So our option 2 will be cancelled out. So now we have to think about our option 3, that is telling us that probability of x n bar greater than c1 for mu greater than mu naught. So under my h1 where our mu is greater than mu naught, the probability p mu when our x n bar is greater than c1 increases as our mu increases, because it is because our xn bar can be approximated by the normal distribution of mu at mu 1 by n. As our mu is tending to infinity, then the probability p mu when our xn bar is greater than c1 is going to 1. So our option C is a correct option of this question. So now we are going to check the statement 4. That is telling us this probability of the median is greater than mu naught. Yeah. So what will happen here? So for a systematic distribution like n mu 1, the median of the sample is distributed symmetrically around mu. Under this hypothesis H naught, our mu is equals to mu naught. Then the probability that the median exceeds mu naught is probability p mu naught when our median of x1 x2 xn is greater than mu naught is equals to half. So our statement 4 is also a correct statement of this question. So our correct answers of this question are my A, D and B. Hope you understood, guys. Thank you.